We are ready to move on to 3.6, and this lesson will be on compound inequalities. So today's date is going to go there. You can see your list of table of contents, and we can start the intro video. So you can see the title, 3.6, Compound Inequalities. You should have that written at the top of your notes. A compound inequality is going to be two simple inequalities that are combined with an and or an or. So what's a simple inequality? That's what we've been dealing with this whole time. A simple inequality could say x is greater than 2. If you notice, it has just one inequality. That makes it simple. What we're going to see today, and then what that looks like, here's 2. You'd have an open circle and you'd shade everything to the right. So what we're looking at today is where you have two inequalities. So you're going to have two of these, and it will be combined with an and or with an or. So if you think about what we're saying, I could say, I have more than $2 in my pocket. That's a pretty simple way of saying something. You also could say, I have between $2 and $10 in my pocket. And so that's kind of what we're looking at. Maybe there's a little bit more information, so we get a compound inequality to represent what's happening. Here are some shading rules. This will make more sense when I go through some examples. You can see the or, and these could be open or closed circles, but you've got your circles, and the or, what I want you to notice is that it's shading out from each other. So one way of remembering this, it's kind of like if you were to picture an oar on a boat. The oars on a boat would go out to the side, just like these go out to the side, shading in opposite directions. So we're saying x could be less than this value, or x could be greater than that value. Now the and is you're shading everything in between your two circles. So you're saying x is going to be greater than this number and it's going to be less than this number, which is why we end up shading everything in between. So just write those down in your notes. That'll make sense when we do a couple examples. So this is what an or inequality could look like. We have -4 plus a is greater than 1, or -4 plus a is less than -3. So for these or inequalities, and an or is easy to spot because it has the word or written right in it. What we're going to do is we are going to solve each inequality separately, and our final answer will have that or in there. So on the left side, I have a -4. I'm going to go ahead and add 4 to both sides. So I'm kind of thinking about these as two separate problems right now. I carry down my a is greater than 5. And then on the inequality on the right side, I'm going to go ahead and add 4. That cancels, so I have a is less than 1. So a can be greater than 5, or a could be less than 1. I have solved for the variable on each inequality, and now I'm ready to graph this. So when I graph these, I definitely need to have a 1 and a 5 because that's where the circles are going to go. I also like to throw in where 0 would be. 0 would be right there, just to kind of show how everything is spaced with each other. So the first one we're going to do, a is greater than 5. So on the 5 over here, I'm going to do an open circle because of the greater than. So open circle, there it is. And then because a is greater than 5, I'm going to shade to the right. All right, now the next one, it says or a could be less than 1. So I need to come over here to 1 and put a circle. That's going to be another open circle. And a is less than 1, so I'm going to shade to the left. So this is what a compound inequality looks like on a number line. I've got my a is greater than 5, that's this piece right here. So a could be any of these numbers out here, or a could be any of these numbers that are less than 1 out there. I know for sure a is not going to be equal to anything between the 1 and the 5. All right, so another example, I can see that this one is an OR. So that tells me, let me solve them separately. So I have 4x is greater than or equal to 20. So we go ahead and divide by 4. That's going to give us x is greater than or equal to 5. Or I can go ahead and bring the OR down now if I want. Over here I'm going to divide by 3 on both sides. So x is less than 10 doesn't divide by 3, so 10/3. Here's the only time when I think mixed numbers are helpful. If you rewrite this as 3 1/3, that's going to help us know where it is on a number line. Alright, so we go to graph these. We're going to have 2 circles, one at 5 and one at 3 1/3. So here's 3, 4. Because of that 3 1/3, I'm going to show where that 3 1/3 is. 3 1/3 is going to be between 3 and 4, and it's going to be about 1/3 of the way. So it's going to be right there, 3 1/3. Alright, so first I need, according to this, a closed circle at 5. So we'll go ahead and put a closed circle at 5. And x is greater than or equal to, so I'm going to shade to the right. Or x is less than 3 1/3. So at my 3 1/3, I'm going to have a closed circle, and then I'm shading to the left for the less than. So you can see this OR inequality, they shade in opposite directions. So a lot of times we'll say, does it shade out or does it shade in? Your ORs will always shade out, just like the ORs on a boat. All right, that takes us to the and inequalities. So I have the word and typed up here, although a lot of times we don't see the word and as part of the problem. Here we have -5 is less than x plus 1, which is also less than 2. So you can kind of think of it two ways. You can look at just this first part and say -5 is less than an x plus 1, and the x plus 1 is less than the 2. So what I notice on these is you basically have 3 sections. You've got this section over here on the left. You've got your middle section, that's always where x is going to be, and you've got this section over here on the right. So our goal is to go to where the x is, which is in the middle. So on your and inequalities, x will always be in here. And you want to get everything else out. So the thing with getting it out is it has to go out to both sides. So we're going to solve the inequality just like we normally would. We have x plus 1 in the middle. Let's go ahead and subtract 1, because opposite of adding 1 is subtracting 1. So the new idea here is I'm going to subtract 1 from the other side, but I also have to subtract 1 from the other side over there. So whatever you do in the middle to get x alone, you're going to do on the left side and the right side. So that cancels. I can rewrite this. -5 minus 1 is -6 is less than x, which is less than 1. And this is solved. We have x alone in the middle. So on a number line, here's -6. This is where 0 is, and 1 would be right there. Our circles, we're going to have an open circle at 6, -6, sorry, an open circle at 1, and then I'm going to remember, I know that my and inequalities always shade into each other, so everything in between gets shaded. So that's telling us that x could be any number that's in between a -6 and a 1. Alright, so here's another and inequality. Again, if it didn't say the and, which oftentimes it won't, I can see, first of all, there's not an or, so it can't be an or inequality. They'll type out the word or for you if it's an or. And you've got your 3 sections. You've got the left section, the middle section, and the right section. So to solve for x, we go to the middle where x is, and we start undoing this. First thing we would undo is that -1. So let's go ahead and add 1. But remember, you're going to add 1 everywhere, on the left, the middle, and the right. So you're adding ones, your ones cancel in the middle. We have 9 is less than 3x, which is less than or equal to 12. Now I go back to the middle and I notice, well, there's still a 3 there, so we're not done solving. So let's go ahead and divide by 3, but I'm going to divide by 3 everywhere. That cancels. 9 divided by 3 is 3, is less than x, which is less than or equal to 4. And because x is alone in the middle, I know that I have solved this completely. On a number line, we are going to, it's just a 3 and a 4, so here's 3, here's 4. On the 3, we have an open circle, and the 4 has a closed circle, and then it's an and, so we shade everything in between. Alright, last slide of the intro video. If you have to write the inequality from the graph, that's what we want to talk about on this slide. So you can see this first graph. I know it's going to be a compound inequality because I have 2 circles right here. So the question is this an and or is this an or? Well, because they're shading out from each other, that's going to be an or. So the ors are kind of nice. You want to go ahead and write inequality for each circle. So the first one, I'm going to write inequality for this side. That side, remember you put the x on the left, the -8 on the right. It's a closed circle and we're shading to the left, so that's going to be less than or equal to. So this right here is x is less than or equal to -8. Or x could be over here on the right, so I have x, I have the -1, so always put the variable on the left side, and then we're shading to the right and it's a closed circle, so greater than or equal to. And that is your compound inequality from your graph. Alright, this next one you can see that the shading is happening in between the 2 circles, so this is what an and looks like. So we can just keep in mind, okay, this is an and. Now with an and, you've got 3 sections. You've got the left, the middle, and the right. Well, the left is going to be the circle on the left. That's a -4. The x is always in the middle, and on the right will be the circle on the right, which is a +1. Now, I don't know if you noticed, every single and will have less thans. So -4 will be less than x, which will be less than 1. We just have to figure out, should we do less than or equal to? And the way we figured that out depends on the circle. So at the 4, you can see an open circle, so we're going to say less than. At the 1, we have a closed circle, so on a closed circle, we're going to say less than or equal to. And that is your inequality written from the graph.